Hello, and thank you all for joining me today. I am Shanna DaCosta, Fluor's AWP Regional Manager for Canada. In this role, I oversee the support of all our AWP programs implemented on our projects across the nation. Today, I would like to present an overview of the Advanced Work Packaging program currently deployed on Fluor's largest project in Canada, the LNG Canada project. This presentation will illustrate the AWP planning lifecycle on the project and will cover the strategic AWP activities deployed throughout each project phase. I will tell you about the project team, what they've done to tailor the Fluor's AWP program to the complexity and magnitude of this project, and how the AWP project team continues to strive towards improvement of the overall project delivery. Also joining us today on the line is Silvana Lara, who is our Global Advanced Work Packaging Director, and Corey Fisher, who is a Senior Project Director at Fluor and currently assigned to the LNG Canada project as our Performance Integration Manager, leading the AWP program with Alan Vipun. Silvana and Corey will join me today to answer any questions that you may have during the last 15 minutes of our session. Let me start with a quick safety topic. The LNG Canada project will achieve their ambition of being the safest project on Earth, founded on caring for people, and their Safer Together program that embodies Fluor's commitment to a caring, preventative safety culture across our organization will be woven into each stage of the project and complement our commitment to never compromise the well-being of our people at work or at rest. While all four pillars are equally important, I would like to draw your attention to the planning and execution pillar. In the earlier phases of the project team through AWP, constructability and construction, participation in model reviews ensured that the design incorporated safe construction and operations considerations wherever possible. Now, during the fabrication and construction phases of the project, the Workface Planning teams carry forward similar attention to safe construction and operations and works to identify special safety considerations throughout the detailed construction planning and development of installation work packages for the module fabrication and site construction execution. So through Safer Together, Workface Planning gives crews time to understand special safety considerations and incorporate them into their job safety analysis in advance of starting their work. This world map and captions here show the various design centers and locations for the project and their associated scopes of work. The LNG Canada project, or LNGC for short, involves the engineering, procurement, fabrication, and construction of an LNG export facility that will liquefy surplus Canadian natural gas so that it can be safely exported to help meet global energy demands. This facility will initially consist of 2 LNG processing units, referred to as trains, each with a capacity to produce at least 6.5 million tons per annum of liquefied natural gas per train. Fluor has had a strong presence in Canada for nearly 70 years, safely delivering engineering, procurement, fabrication, and construction services to some of Canada's largest oil, gas, petrochemical, mining, power, and infrastructure projects. With Fluor's joint venture partner, JGC, the project will be performed by leveraging the global capabilities and expertise from both companies, with project work to be executed from our North America and Asia Pacific offices. To give you some context around the project scope of work, this is the overall project plot plan. Phase 1 of the plot plan that you see highlighted here is included in Fluor's and JGC's scope of work. At peak, we had approximately 2,800 home office staff. Our construction stage 1 of the project, which is the early works, is substantially complete and included site mobilization, site preparation, camp and temporary facilities construction, material offloading facility, and the product jetty. We are currently completing stage 2 of the project, also known as getting out of the ground, which includes our piling, undergrounds, foundations, and paving, and the river water intake. And we are preparing for stage 3 of the project, which includes the bulk construction of 19 utility units and 12 permanent buildings, including module installation, heavy lifting, stick-built scope, LNG tank, and other EPC work. Stage 4 of the project is completions, which will include turnover and commissioning activities. At peak, we are forecasting about 7,500 total construction personnel, including those on rotation. And Phase 1, Trains 1 and 2, is a lump sum EPFC contract with reimbursable startup support. If you haven't already grasped the enormity of this project, here are a few facts to help put the size and scope of the LNGC project into perspective. This photo on the slide shows the size of the modules compared to the Sydney Opera House. As I mentioned on the previous slide, there are 19 of these utility units. Some key quantities worth noting include 4.1 million metric tons of site fill, 7,675 piles up to 1.5 meters in diameter, 177,000 tons of steel, 373 pieces of mechanical equipment, 463 kilometers of pipe, which is 70% in our modules, 3,250 kilometers of cable, which is 35% in our modules, and 256,000 tons of modules. The LNGC project team developed the AWP mission statement that you see here. Consistent with Fluor's construction-driven execution and advanced work packaging corporate process is this illustration. The LNGC AWP program drives the project team to ensure that considerations of each future phase of the project is accounted for and committed to in the earlier phases of planning throughout the entire AWP planning lifecycle. In the next set of slides, I will explain more on what this truly means to the LNGC project team in terms of their effort, processes, data, and control measures that needed to be put in place. The AWP implementation plan summary for the LNGC project includes, as per the prime contract, the joint venture between Fluor and JGC, commonly referred to as the JFJV, is required to implement AWP philosophies and methodologies across all project phases and design centers, our fabrication yards, and at site. This is a monumental task for the project team given the size and complexity of this project, but the project team has managed to meet this requirement through the project's AWP philosophies and methodologies, developed and implemented specifically for this project. LNGC's robust AWP program complies with Fluor's standard AWP practices and procedures, and many of the developments made so far on the LNGC project contribute to Fluor's corporate standards and procedures improvements and for the overall capital project delivery. Before we dive into the specifics of LNGC's AWP program, it's important to highlight the LNGC's project team culture and alignment that leverages the power of AWP to drive successful project planning beginning with the end in mind. Throughout the project, beginning with early planning and execution activities, from project setup to completions and turnover, the LNGC team focused and continues to focus on alignment of all the key project team functions that you see here, including all JFJV personnel, our clients, our vendors, and our suppliers. The LNGC project team focuses on establishing a culture that has a holistic approach, has aligned teams, is proactive and collaborative, has trust and respect, shares knowledge, and focuses on well-defined solutions. This AWP culture fits well into the overall guiding values of the project, which are professional, aligned, and respectful. The AWP culture and the people on the LNGC project are the cornerstones of AWP implementation. To capture the essence of the AWP culture and ensure that all members of the project team have a comprehensive point of reference for the AWP program, the project team collaborated and produced key documents, including plans and procedures that outline the AWP philosophies, methodologies, operational rules, and overall AWP requirements needed to maintain alignment and unity across project functions. So here's a list of some of the key project documents produced by the project team. Let me point your attention to the AWP implementation plan that includes the AWP requirements for the JFJV and its subcontractors in accordance with the prime contract and the project execution plan, and the Workface Planning execution plans issued by the JFJV's subcontractors and by Fluor for our self-performed Workface Planning scope. The Workface Planning training program on the LNGC project is also a key component of the AWP implementation and its success, and the Workface Planning training modules developed for the project are what you see here. The objective of these training modules are to equip all key members of the JFJV project team, including its subcontractors, with the right information and skills to perform their AWP-related roles and responsibilities on the project. In parallel with AWP setup activities occurring during the project initiation phase, the project team led by Project Controls established the Work Breakdown Structure, or WBS. Construction played an important role in this activity while they worked closely with engineering to define the construction work area boundaries and the path of construction. The specific construction work package geographic boundary codes, known as the partition, subpartition, and stage codes, were also defined in the WBS. The CWP execution code list defined during this phase included all applicable types of fabrication and construction execution codes necessary for the project scope. The execution code in the WBS allows for the allocation of material, effort, and criteria for the reporting of scheduling and progress for the project to be realized at a CWP level. Finally, the scope code of the WBS was defined to include all applicable types of work for the project at a discipline level. The scope code is similar in nature to a project discipline code, such as piping, mechanical, structural, etc. Ultimately, with this logical coding, the WBS represents the way the project work was defined, is planned, managed, and controlled, and allows the LNGC project team to define CWPs and IWPs that are uniquely linked to their associated technical information, materials, and data. You may notice here that the LNGC project WBS has no unique code for engineering work packages. The reason for this is that at Fluor, our AWP program includes a unique twist on the CII and COA best practices. Fluor's integrated EPFC execution merges the recommended EWPs and CWPs into a single deliverable. Our innovation and associated proprietary work processes tailored to our automation and execution approach helps eliminate paperwork redundancies and reduces engineering effort hours from a project. Along with the WBS, the project team defined key points of alignment and integration between project controls and AWP. These points of alignment and integration were identified during the project initiation phase, but their subsequent work processes and activities are continuously being refined as the project progresses. So some of the key points of alignment and integration are the CWA and CWP level planning, considering path of construction, constructability, and system turnover, where project controls develops the level 2 schedule, which is the CWA level schedule, during the project initiation phase, and develop the level 3 or the CWP level schedules during the detailed engineering phase. And the CWP release plan was defined during the detailed engineering phase with planned, actual, and forecast CWP release dates. We also have the progressive control level planning, which is the IWP level planning, considering IFC quantities, rates of placement, and rules of credit for self-perform work, where project controls develops the level 4 schedule, which is your IWP level schedule, and the 30, 60, 90-day look-ahead schedules. And the IWP release plan is being defined during fabrication and construction phases with planned, actual, and forecast CWP release dates. We also have the progress measurement considering our IFC quantities, rates of placement, and rules of credit for self-perform work, where project controls measures progress with a roll-up to our prime accounts, our CWPs, and our systems. And the progress is reported as IWPs are progressively completed and closed out. Reporting considering percent complete and performance factor is also considered. By associating CWPs and IWPs to schedule estimates and progress measurement, the LNGC project team ensures that IWPs will be consistently planned and controlled in accordance with the project's overall baseline. This enables all members of the LNGC project team to work toward achieving shared goals and key performance metrics. Nearing the end of the project initiation phase, the project team established this overall AWP process with strategic activities that drive the AWP implementation. The project team defined 3 lines of defense or checkpoints to ensure project deliverables aligned with fabrication and construction requirements, and crews have all the elements necessary at the work fronts before the work is started. So the first line of defense is where the project team reviews the CWPs with all stakeholders to ensure completeness prior to CWP release for fabrication and construction. The second line of defense, having developed IWPs using sound fabrication, construction, execution judgment, and sequencing in accordance with our level 4 schedules and completing IWP Constraint Management, to confirm the IWPs include all the latest IFC technical information and the materials available. Workface planners review the IWPs with Frontline supervision to ensure IWPs are fit for purpose and complete prior to issuing for construction. The third line of defense is for Frontline construction supervision to perform short-range planning, which includes final coordination and clearance of construction mitigated constraints, also known as scaffolding, accessibility, permit issuance, and the availability of construction equipment and specialty tools. So although the project's AWP process is well defined in terms of activities and timing of these activities, the project team promotes the AWP culture and focuses on collaboration and change management in order to allow for flexibility and agility when performing these activities. So the AWP process on the LNGC project is one of the last activities to be confirmed during the project initiation phase and AWP setup because of the alignment and buy-in that is required from all leadership and other functional stakeholders on the project to ensure successful AWP implementation. After the AWP process and strategic activities for the project was defined, one of the key activities was the selection of the AWP automation tools and the alignment of data requirements. The AWP automation tool selection and data integration was initiated during the project initiation phase, but was finalized and refined during the detailed engineering phase. This is an important activity in the AWP process on any one of our projects, but especially on a project with this size and complexity. With a goal to maintain integrity and control of the data throughout the AWP planning lifecycle, the LNGC project team focused their time and effort on automating as much of the AWP effort as possible. These are the automation tools that were selected and set up specifically for this project. As you see here, we have S3D, which is used by the JFJV as our 3D design model, and for CWP data and preliminary IWP scoping. We have EPC Integrated Console, also referred to as EPIC, which is an internal tool developed by Fluor and is used by the JFJV as a data hub and for AWP dashboards. The 4 main aspects of EPIC are data collection, data processing, validation and analysis, automated data integration, and integrated work processes and notifications. We also have Smart Construction, used by the JFJV for our OSBL and ISBL, IWP, and HydroChest package development. We have O3, which is used by JFJV, Fluor's module fabrication yard for IWP development and carryover work, and IWP constraint tracking and reporting. And O3 is also used by JGC in their module fabrication yard for carryover work. Mods Virtual Manager, used by JGC in their module fabrication yard for ISBL CWP data management and IWP development for module fabrication. We also have Envision used by the JFJV for IWP scoping, IWP status, and material status visualization. And then we have 4D simulation software in sequence and Synchro 4D. As with any automation tool, the key to its functionality lies within the integrity of the source data. As such, the LNGC project team invested a significant amount of effort with each engineering discipline in aligning the data attribute requirements that would be published in the 3D model data for fabrication, construction, startup, and commissioning purposes later on in the project. The data requirements established were not only to set expectations and maintain consistency of the data during design, but were established for vendor and fabricators' data integrity as well. The development of CWPs is a key component of the LNGC project's AWP program and the overall project delivery. The use of CWPs helped confirm that engineering deliverables support the fabrication and construction planning efforts, starting from pre-planning to turnover and completions as an integrated process between all key stakeholders. The LNGC project team involving fabrication, construction, and engineering personnel defined CWP scopes and boundaries by using a combination of methods that incorporated contracting strategies, the path of construction, modularization, and constructability into the engineering package design and delivery. With this effort, the LNGC project team was able to improve the communication between fabrication, construction, and commissioning that ultimately led to an improved Level 3 schedule that drove CWP releases for construction. Model and constructability reviews, implemented through a team effort, involve the client project team, engineering, fabrication, and construction, including vendors, suppliers, and subcontractors, and optimize the use of fabrication and construction knowledge and experience in CWP planning, design, procurement, and field operations on this project. This effort helped the LNGC project team confirm CWPs were also fit for purpose for fabrication and construction purposes. As the path of construction, including final setting sequence for modules and equipment, was refined, the engineering and procurement deliverables sequence and prioritization by CWP was set as a baseline and formed the Level 3 schedule and CWP release plan for the project. The detailed class estimates were also based on CWP material takeoffs and were refined as the design matured. Finally, the LNGC project team mapped the master drawing register, the MDR, to CWPs to help with change management and transparency on actual engineering percent complete. The timing and setting of this baseline and performing class estimates was a strategic and critical for the LNGC project's key quantity tracking, cost forecasts, and change management. Once the CWP development reaches a level of maturity and approaches the 30, 60, 90-day look-ahead schedules for CWP issued for construction release, as per the Level 3 schedule and CWP release plan, the LNGC project team initiated the CWP release reviews to determine the readiness of CWP releases. When it comes to tracking and reviewing CWPs, the project team has a couple of valuable tools at their disposal, one of which is their CWP checklist dashboard in Epic that you see here. This dashboard pulls data from the project suite of tools and displays all the data that is tied to a CWP in one convenient place. Using this dashboard, the project team was able to visualize any status discrepancies of the data associated with a specific CWP. The primary information reviewed during these CWP release reviews included our Level 3 schedule, technical document IFC status, material status, including material schedule, RAS date complex, and 3D model data status by CWP, including model errors that may compromise fabrication and construction efforts. This dashboard is also extremely important in the project team's CWP Scorecard effort. In order to expedite the CWP release reviews and CWP release for construction, the project team, led by the construction automation manager, created this automated scorecard. Construction and fabrication utilizes the CWP scorecard during the CWP release reviews to help engineering expedite resolution of errors, discrepancies, or missing information prior to release of the CWP IFCs. The form that you see here pulls the data from the CWP checklist dashboard and displays relevant information automatically. Automating the capturing of CWP errors, discrepancies, and missing information also allows the project team to evaluate any trends that may require improvement. It also allows the LNGC project team to assess whether the percentage of CWPs being reviewed needs to be increased for quality purposes. Transitioning into the module fabrication and construction phases of the project, the LNGC project team through Workface Planning focused on developing and managing fit-for-purpose IWPs that drive progressive completion of bulk construction in the module fabrication yards and at sites. In order to promote consistency in workplace planning and execution across JFJB's module fabrication, construction self-perform, and subcontract construction work, the project team defined the workplace planning requirements in all applicable subcontracts. Here is a summary of the division of the AWP responsibilities between the JFJB and their subcontractors. So for JFJB AWP roles and responsibilities, these include providing AWP program governance and maintaining cross-functional focus on optimizing project delivery, driving optimization across project phases and aligning all stakeholders, supporting and removing of constraints pertaining to CWPs, and facilitating integration and providing guidance and approvals. The JFJB also provides AWP and workplace planning training to all project personnel. So for module fabricator and subcontractors AWP roles and responsibilities, these include implementation of their workplace planning program in accordance with the project's AWP requirements. One of the main deliverables from all entities who are implementing workplace planning is the submission of a workplace planning execution plan that includes the subcontractor specific workplace planning requirements, including their methods, procedures, and automation tools, if applicable. Consistent across all entities implementing workplace planning is the IWP template that you see here. The IWP will be produced by workplace planners at the module fabricator yards and at site. Workplace planners on the LNGC project are responsible for the development, monitoring, and control of IWPs, which includes scoping IWPs within CWP boundaries, scope and schedule, confirming IWP plan start and finish dates with project controls. So this is important for IWP release plan validation with the 30-60-day look-ahead schedules and progress base. Reviewing IWPs with construction supervision to confirm IWPs are fit for purpose. Performing constraint management, ensuring that all technical information is available and accurate. All materials are accounted for, including owner, vendor, and contractor supplied materials. All construction mitigated constraints are accurately identified and planned for, including scaffolding, construction equipment, specialty tools and equipment, and permit requirements. And prior to release IWPs to superintendents for construction execution, ensuring that IWP content is complete and accurate, and that all technical information and material constraints, including release of field material requests for material bagging and tagging purposes by IWP, are cleared. And finally, monitoring IWP status, including IWP closeout, with project controls and turnover to promote progressive completion of bulk construction. The module fabricators on the LNGC project implement their own unique workplace planning program that complies with the JFGV's AWP program requirements for the project as previously mentioned. One of the main differentiators between the module fabricators workplace planning programs and the workplace planning program that you see on site is the breakdown of CWPs into IWPs. At the module fabrication yard, the module fabricator workplace planners consider the module fabrication execution strategy most appropriate for module assembly. So for the very large modules, or VLMs, it is common for Fluor's module fabricator also known as COEC Fluor Heavy Industries, or CFHI, to use the pancake assembly methods or a combination thereof to construct the modules. In this case, an IWP scope and boundary will typically represent one level of the module. Similar to construction execution at site, the module fabricator workface planners will apply sound construction judgment and consider variables such as accessibility, safety, availability of construction equipment and tools, and people power when developing their installation work packages. CFHI's workface planning process is similar to the workface planning process that is implemented for JFJB's self-performed construction at site, except CFHI uses O3 on build for their work packaging. With O3 on build, CFHI is able to manage and track the release of CWPs, create, manage, and monitor IWPs, provide visualization of IWP scopes, and manage IWP constraints. Similar to the module fabricators, most of the JFJB subcontractors are implementing workface planning at site. So for the JFJB self-perform scope at site, workface planning covers the mechanical, piping, electrical, and instrumentation and structural scopes. And for the JFJB subcontractors at site with workface planning, scope of work includes the piling, earthwork, and civil, marine and heavy civil works, concrete, some electrical and instrumentation, piping, pipeline, insulation, and refractory, and architectural and buildings. At site, workface planners use smart construction for their IWP development, with the exception of some JFJB subcontractors who have their own JFJB approved suite of construction automation tools. So smart construction is JFJB's workface planning tool that allows workface planners to electronically create and manage installation work packages. So its primary focus is on supporting workface planners' activities, including the model visualization and data filtering capabilities, effort hour calculations, task lists for packaged objects, material list creation, and material forecasting. So smart construction is an add-on module on top of our smart plant foundation, which means smart construction has a direct integration with the published 3D model data for the project, and users can package objects directly from the published 3D model data. So once an IWP is complete and ready for IFC, smart construction creates a compiled PDF which contains all the information needed for the construction crew to perform and complete their task. Constraint management is a critical activity in all workface planning efforts on the LNGC project, and the JFJB project team actively manages constraints for their self-perform work and oversees the subcontractors' IWP constraint review sessions on a weekly basis. So the types of IWP constraints managed and controlled by the workface planner are the constraints pertaining to CWP IFC information, such as drawings and materials. This allows the workface planners to issue a constraint-free backlog of IWPs for the 30, 60, 90-day look-ahead schedules and for short-range planning efforts. So the management of all IWP constraints occurs during the IWP constraint reviews, where all outstanding constraints are reviewed with Frontline construction supervision and construction coordinators, and actions are allocated, and the status of each IWP is agreed and tracked in O3. The project team works efficiently and iteratively to clear all constraints before an IWP is released to the field for execution. If IWP constraints cannot be cleared prior to the scheduled start date, AWP and construction managers or their delegate will decide on whether the IWP should be resequenced or rescoped. O3 Insight is used to report and track the package status and the individual constraints of IWPs on the project. So both in the module fabricator's yard and at site, O3 Insight tracks all the IWP constraints. So O3 Insight also allows users to create constraints, update and view open constraints, and emails the owners of the constraints regularly to remind them that they have actions to close out. The workface planners develop and maintain an IWP release plan as IWPs are developed and constraints are cleared and IWPs are released for construction. So the IWP release plan includes IWP number and descriptions, planned effort hours and quantities, IWP approval status, planned start date, and finish dates. And the IWP release plan is used by Workface planners to ensure that IWP start and finish dates are within their CWP construction start and finish dates as per the level 3 schedule. And once IWPs have a constraint-free status, they become part of the 30, 60, 90-day look-at schedules. As such, the IWP release plans are used for fabrication and construction schedule validation. Overall, O3 is used as a single source tool for the development and management of JFJBs and subcontractors' IWP release plan. On the LNGC project, the final step of Workface planning before construction execution starts is for the frontline construction supervision assigned to an IWP to perform short-range planning. This occurs typically within 2 weeks of planned construction start dates and includes performing final reviews of look-ahead schedule activities, committing to IWP activities pending construction mitigating constraints removal, generating a weekly work plan, and discussing risks, opportunities, and safety with their crews. Once the work is completed, Workface Planning works closely with frontline construction supervision and coordinators to ensure timely IWP closeout. So construction reports actual installed quantities for each work step as the work progresses for each IWP, including actual start and finish dates. Any unfinished work is replanned. And the Workface Planning and systems completions and turnover teams support the transition from bulk construction to systems completion. So in order to help support progressive turnover of bulk construction, the project team, including AWP and systems completion and turnover, work closely throughout the project to align their work processes, systems, and tools. As an IWP may span multiple systems and subsystems during bulk construction, the LNGC project team ensured that the CWP and IWP breakdowns include the completion system numbers. This enables the IWP sequence plan dates to be aligned with turnover systems and a planned transition from bulk construction to system completion to be realized. The project team also created a transition to completion dashboard that provides data outlining the association between IWPs and inspection test records, or ITRs, and systems. This dashboard that you see here also assists for auditing outstanding ITRs against completed IWPs with statuses of construction complete, final acceptance, and closeout. And more specifically, as the turnover process is done on a system-by-system basis, each IWP and the status of the work activities within the IWP were directly tied to a system using the process system ID and electronically assigned elements of the IWP to the parent CWP within the design model. In summary, the LNGC JFJB project team, through early involvement between key stakeholders and functional representatives, has effectively implemented AWP on the project to date. And so far, the alignment and timing of the sequence of engineering deliverables with procurement, fabrication, and construction requirements has been maintained and controlled. Today, as the project leads into stage 3, which is the bulk construction phase at site, the project team continues to focus on delivering fit-for-purpose IWPs to the crews, so the crews remain safe and productive. So I'd like to extend a big thank you to the LNGC project team for all of their efforts to date, and specifically thank you to Corey Fisher and Alan Vipon, who are leading the AWP program on the project. The project team is a group of very talented, resilient individuals, and their collaboration, inclusivity, and drive to improving module fabrication and construction execution will, I think, have a lasting positive impact on generations to come. So now I'd like to open the floor to any questions or comments that you may have. All right.
Maxim Grisham has a question, and I'm just going to unmute you, Maxim, but you may need to unmute yourself as well. And then we'll go to Soma for a question. Go ahead, Maxim. Maxim, you can just unmute yourself by clicking on the microphone on the left-hand side of the GoToWebinar control panel. And also, everyone, you can type your question into the questions tab if you like.
Sharon, thank you very much for your for this fantastic presentation. And for my next question, what is the organization structure of, that you can provide quality management of process? First of all, I am interested in IWP because you need additional staff. This is the first question, of course, and what the competence level of the staff. This is not. I think it's not. You need high qualified specialists for this. Could you please explain a little bit more requirement for qualification?
Sure,
and
no
what,
problem.
how many specialists IWP control your workers and all this process, if it's not secret?
Okay, sounds good. Thank you for the question, Maxim. So on the project, and Corey Fisher can jump in at any time here, but on the project, the organization really leveraged the expertise across the CNF organization, not just specifically to planners, but they include construction coordinators. They include obviously our project controls schedulers. They include our quality personnel, and then of course we have AWP leads and an AWP manager, as well as Corey Fisher, who's our project integration manager as well. So there's quite a few, there's a range of positions, let's say, within the organization that has a very varied degree of qualifications that contribute to these efforts. One of the key activities that the LNGC project team did was to make sure that the specific roles and responsibilities pertaining to AWP were clearly defined and shared with each of the individual people that are part of the organization that contribute to the AWP. So for instance, the construction coordinators, they have, along with their traditional, let's say traditional role as a construction coordinator, they also had an element of AWP alignment and integration and planning that they were required to perform. So again, the roles and responsibilities was a key activity to make sure that with such a large organization and such a complex project, that they had clear understanding of what was required of them. I hope that answers your question.
Yes, thank you very much. But we need, in fact, special additional roles for AWP and the Workface Planning process, and we need additional education for these people, for like for all. Like I understand. Okay, thank you very much. Thank you.
No problem. Thank you.
And Soma has a question now. Soma, you can unmute yourself and ask your question.
Hi. Can you all hear me?
Yes, we can. Hi, Soma.
Hi, can you all hear me? Okay. Okay, okay. Thanks, Shannon, for this very insightful and informative presentation. I guess there are a lot of takeaways in your presentation, so thanks for that. So I have just two questions. The first question which I wanted to ask is, I have seen that there are three software packages which are not three. In fact, there are 4 software packages which are supposed to be construction plan, some way or the other related to the construction planning that you have used. SPC, that's the Smart Plan Construction. Then O3 solutions for somewhere. Then Envision in some places, like ISBL, OSBL, and then at the end, I guess there is another one. So I was just wondering, like, if we had to have a global dashboarding or a global status of your the entire project, so wasn't it little challenging to get all this information? And how did you manage, using so many different construction management softwares, and then then still manage it? Or was it like reporting was done only in specific areas? If you could just let us know. This was one question. Second, of course, is do you have any benchmark? It was something related with even the previous question. The person was asking that we need to. It is a proven fact that if you have to go for AWP, we need to increase little bit more effort in our planning stage, especially for IWP. So, do you have any benchmark of what kind of an increment in the construction planning or the overall planning would be required compared to a traditional construction if we go ahead with AWP? So there are two questions. One is there are quite a few different softwares. How did you integrate? And second is, do you have any benchmark for what is the percentage of effort which increases in the planning phase? If we go ahead with the AWP implementation. Is the question clear, Shannon?
Great question, Soma. Thank you for that. So to answer the first question, so within the organization on the LNGC project, we have our construction automation team, and formerly referred to as CATS. They're responsible for setting up the systems and aligning the data and so forth. So they play a key role in AWP and did so on this project. Specifically in relation to using multiple systems, one of the key activities that the project team focused on was the standardizing of the data attribute requirements specific for the project. And so part of the effort in making this alignment was to, one, do it as early as possible. We started this effort during the feed phase, and two, we leveraged and worked with our partners, JGC, and their engineering departments as well, to make sure that we get that consistency and get that alignment with the data. And as I mentioned before, they dove into discipline-specific data requirements that would be represented in the 3D model. So the 3D model being the primary source data for engineering produced data was kind of that hub where that information lied. The project team also developed EPIC, which I mentioned before is a data management tool essentially. So it's really pulling in the data from all sources and making it useful that we can provide it in our reporting and dashboards and so forth. But it started with the data attributes and the consistency of that across all of our design centers, and it's it continues forward as CATS is kind of that central team of expertise to get those systems and data set up. I'll allow Corey, if you have any additional comments to add. I know you've been quite instrumental in this effort as well, if you'd like.
Shannon, it's Corey here. Well, great answer so far. I mean, you're right. It's always a challenge on all projects to get to data integration between systems. But as you pointed out, having those data attribution specs developed early on, and work with engineering to ensure they understood those and followed those specific attribution requirements. But Using the hub was a very critical aspect of what we did, having the Epic data hub set up to validate and check data integrity that came into the hub before we shared with other systems to make it usable and valid, so we didn't have to be worried about that. And having set up the CWP scorecards process using that data, we were able to, many weeks prior to CWP release, check all the data that's coming from engineering to verify it's available and correct, not technically wise, but it's available and aligned across various systems. So that's it.
Thanks, Corey. Yeah, it's quite an effort, and it was quite a focus for quite some time actually on this project. And to answer your second question, Soma, kind of ties in a little bit to I think the data standardization specifically on the project. From a benchmarking perspective, it's quite challenging, as I'm sure most of you have experienced in some way, shape, or form, to provide a benchmark in terms of the level of effort required for AWP. I mean, we know that at the beginning of the project, as early as we can, to get individuals integrated into the project team who understand AWP and who understand how to pull all the parts together to, to create these packages and the construction, the path of construction and so forth, and all these activities. So we know that that's the case. Now, in terms of, additional resources or resources specifically dedicated to AWP, we have our rule of thumb that we apply, which we did on this project. But again, we really leveraged, the project team really leveraged expertise across the ecosystem, let's say, of the project team to perform these AWP activities. In relation to the data, what we're trying to do within Fluor as well is standardize our data in alignment with the CII efforts as well, but also what we're learning from the LNGC project and the amount of data and information that we now have available. It's really contributing to the standardization across our corporation from a data perspective. And what we're hoping for is that when it comes to estimating projects in the future, when it comes to staffing projects and so forth, that we'll have a little bit more of a tangible data set to work off of, so that we can establish that benchmark and really start to understand the efficiencies that we're achieving with AWP. So, Manna, I don't know if you have any specific comments to add to that.
No, thanks. I think it's good what you said, and of course we would. It is. I mean, CII benchmarks are available with us, so let's see. Yeah, I think it's good. Thanks, Shannon and Corey, for your explanation. Yeah.
Thank you so much. We have time for a few more questions.
Yeah, there is a question in the questions tab. I can read it out for you, or you can see it in the questions tab.
I'm actually having a bit of difficulty seeing the question.
No worries. Daniel's question is, what was the owner's role in the process? Were there specific inputs they provided early on or throughout the project?
Absolutely, great question. Yes, so the owner played a very important, significant role in this. We had, arguably for the first time that I've seen anyways, the AWP requirements in our prime contract were very specific, and they were very prevalent, let's say, throughout the prime contract. So it started there, and then from a data perspective as well, the client had a lot of requirements that they need from an operational perspective as well, that they were also asking engineering to provide, let's say, earlier than traditionally speaking. So there was a request, and they were very specific. The clients were very specific with the data that they were looking for, and they had load files, for example, that they requested engineering to provide. So there's that aspect of it. And I think from a construction and fabrication perspective, we really benefited from that. And obviously from the overall AWP implementation, we really benefited from that because we had clients who are very well versed in the AWP process. So they definitely drove the program, which made it easier for us to get buy-in with all our key stakeholders on the project. Corey, do you have anything to add, maybe in relation to the our clients' involvement currently on the project and what that means for AWP?
One of the things I would like to point out is what you already said. I've seen a number of private contracts. Our contract with this client was more detailed than any contract I've ever seen in respect to the expectations around AWP. The good thing is, AFJV and what we do for AWP Workface Planning was fairly aligned with what the client expectations were. So we didn't really have to change anything about what we want to do or what we plan to do, because this is how we do it anyway. But we were very aligned on that, which was good. So we're on the same page for start, and not only for construction, but also for application, because we've implemented the whole program Workface Planning at Fab Yards as well. And knowing as well, I mean, this is a lump sum project. So the client doesn't have too much involvement in the details of how we do Workface Planning, whether it wants a contract, but they support it the whole time. See the value in it.
Thanks, Corey. Hopefully that answered the question.
And Tom has a question. Tom, you can unmute yourself and ask your question, and then we'll go to Annabella's question. Hi, Tom, are you there? Perhaps we'll go to Annabella's question in the meantime. Annabella's question is, yesterday we learned from Cody Austin from Autodesk that not all data lives in the 3D model. Some of the data lives in other tools. How did Fluor program material data from your MatMan system, and which automation tool of the ones you showed in the did the MatMan data feed into to help with MTO and IWP development?
I'm going to pass this question on to Corey because I know that he can speak more to the specifics of that, if you wouldn't mind Corey jumping in.
Okay. Yeah, well, much of our data does come from the 3D model, as you would have seen. Piping, structural, for instance, primary 3D model from our fabricated Tekla models for steel, from steel information from our fabricators. But for electrical instrumentation, we do use SmartPlan Electrical, we do SmartPlan instrumentation. So those other tools do interface with our MatMan material system as well. So to the various tools we have within the SmartPlan suite, we have integrated with the whole program. So we've got electrical information from Spy and Spell and models for structural and mechanical. I hope that answers your question.
Yeah, and I guess the only thing that I would add to that too is, again, going back to the standard requirements that the team established in the beginning. Part of the requirements considered how the data would be consumed in our MatMan system and vice versa. So it was quite a deep dive, let's say, into the data between all of our systems, so that we have that our MatMan system can actually function and be assigned to CWPs throughout the process. So
good point, Shannon. As always, that is a critical aspect of setup of the project from the very start. We did it on other projects prior to LNG speed. We've learned through those projects what we need to do. We did it early on this project, and it's paying dividends.
And excuse me, Corey, I've got a comment that you're sounding a little garbled, so I'm not sure if you're.
I'm at the field office, actually.
Okay, there you go. Okay.
So I was worried about
All right.
the actual connection.
Okay. And Tom, if you'd like to go ahead, I see your hand is still raised. I have unmuted you, and if you just click on unmute or click on your microphone icon, then you can go ahead and ask your question, and then we'll go to Carl's question. Oh, sorry, there's two other questions after that. Okay, we'll go to a different question while we're waiting for Tom. And the question is, what are the biggest challenges of AWP implementation to a joint venture? And that is coming from Carl.
I think one of the biggest challenges, and I can speak to one of the challenges that we experienced early on in the project, but one of the biggest challenges was that, of course, JGC is an expert in their own right, and they have a mature AWP program as well. So aligning the two programs
Sorry, I'm in
was a bit of a challenge, but at the same time, from a philosophy standpoint, JGC and Fluor had quite similar philosophies, obviously in AWP, as you can see throughout this conference as well. So it was really, I think, in the details of the information, the data that their engineering would provide, when they would provide it, and how they facilitate that program on their side, on their end. So although we had we started from a great point because similar philosophies in AWP, but when you get into the details, it can become quite challenging to integrate. But having a sole data management hub like we do with Epic really allowed for both JGC and Fluor, I think, to have flexibility in how they produce the data and when they did in certain cases. So we had a few layers, let's say, of alignment that was required. So from that perspective, it was a bit of a challenge. But again, like I said, when you're starting with a joint venture who has very similar approaches to AWP, it makes the process a lot easier to navigate.
Shannon.
Hi,
Shannon, if I can add to that question, definitely the role of the client with a well-defined requirements on the contract, on the brand contract, what they expect from the AWP program help a lot, correct? It's not what one part of the joint venture want or the other part, is how to meet the requirements from the client. And that was really well defined from the beginning.
And to add to that, you can hear me, Shannon, on the project, well, we already said it's a mega project, and we set up a joint venture directorate team, or a core team as well, to help ensure consistency across the partners and specifications and project directors we developed to make sure we were consistent early on in various aspects of the project, one of them being the engineering data and how we would do model and what we would model and the tools we would use to integrate the whole program.
Yes, thank you, Savannah and Corey. I guess the other thing that we will see during bulk construction is when it comes to the carryover work from the module fabricators, there's been a huge focus from the project team to make sure that as a joint venture, we approach managing punch lists and carryover work from our modules in a very consistent way. So there's a few measures that were also put in place in that regard to make sure that we get the consistency at site, because of course now that's where all of our scopes merge into one. So do we have time for another question, or?
After this, there is only a lunch break. So
Okay.
I'm just checking with some Maxon's hand still appears to be raised, but I'm just checking with him if indeed his has another question. Other than that, the questions tab, we've gone through it, and nope, and Maxim does not have another question. Thanks,
right.
Maxim.
Thanks, Joan. And thank you everybody for attending. Thank you, Silvana and Corey, for helping me out here. And Corey, please extend the thanks to the team, the project team. So again, enjoy the rest of the conference and appreciate your time today. Thank you.
Have a great day, everybody.
You too.